Leetcode 674, longest continuous increasing subsequence. Let's get started. Given an unsorted array of integers, nums, return the length of the longest continuous increasing subsequence, i.e. a subarray. The subsequence must be strictly increasing. A continuous increasing subsequence is defined by two indices, 1 and r, where 1 is less than r, such that it is nums 1 plus 1, and so on. For each one, 1 is less than or equal to I, less than or equal, or less than right. Okay. And then nums at some index is less than or equal to nums I plus 1. Okay, let's look at some examples. This is sort of confusing. All right, so we have a sorted array, right? That's what they say. Given an unsorted array of integers, return the length of the longest continuous increasing subsequence. This subsequence must be strictly increasing. Okay, so here they say the output is 3, and this is our given input. So 1, 3, 5, 4, 7. So strictly increasing is the 1, 3, 5. Yeah. And that subsequence's length is 3. 1, 3, 5, 7 is an increasing subsequence, but it is not continuous. Its elements 5 and 7 are separated by element 4. Okay, so they have to be consecutive elements. That's sort of where the continuous is coming from. Yeah. Okay, so then let's look at the other example. 2, 2, 2, 2, 2. Okay, so basically this example tells us that it must be strictly increasing. So like duplicate elements would represent a break in the chain of consecutive or of continuous increasing value. So strictly increasing, this test case would not have any set of characters or any set of elements in the input array nums which abide by that, or abide to that rule, if that's the right way to say it. Okay, so we have some constraints here. The length of our nums array is always greater than or equal to 1 and less than or equal to 10 to the 4th. And it looks like we're dealing with some very potentially large numbers. Okay. Okay, cool. Gonna paste in my PDAC. Okay, and let's get some space going. Okay, so let's think about this. As far as our input is concerned, we're dealing with an integer array of length 1 or greater. Length 1 or greater. And they do specify that it is integers only. And what we want to return, so when we run our function, what we want the return value to be is some number representing length of longest continuous increasing subsequence, which is really just a subarray. Okay, and that's actually that's not intermediate, that's output. Okay, so we kind of have our endpoints here as far as where we want to go, and where we want to start and where we want to end in terms of the data. Let's identify some of the requirements that they explicitly express in the problem description. Okay, so strictly increasing means essentially number. So if we think about like a list of characters like this one here, this number at index 0 and this number index 1, you can think of them as like left and right. So left number must be less than but not equal to right number in order for it to be considered strictly increasing. And as far as like the continuous nature is concerned, that's essentially we read that as consecutive. Consecutive. I think that's how you spell that word. Consecutive. Okay. So one after the other. So like index 1, index 2, and so on. Okay. So there's just like some general problem specific requirements from my understanding of this problem so far. Let's think. Yeah, they even use left less than right. Okay. And they say that there will be negative numbers. So if we're thinking like, we just grab this test case, let's just iterate on that a bit. Maybe if it was like 1, -3, 5, 7, or 5, 4, 7, then the output from our function should be 2, because the longest continuous increasing subsequence would be 4 to 7. Okay. Because this would represent a break in the chain of consecutive increasing subsequence of characters or of elements. Okay. And we don't have to worry about like an empty array because they specify that the input array is always of length 1 or more. Okay. I think I have a pretty good understanding of most of what this problem is about. Just gonna let my dog in real quick. Okay. So we can start thinking maybe a little bit about, I can't really think of any edge cases here. Sorry, my dog's whining. Okay, so reading. Okay, so I think we understand this problem pretty well. It's fairly straightforward. So I think I'm gonna get into maybe just describing it in English. So in terms of a summary, essentially we want to find the longest consecutive sequence characters contained in integer array nums, and return that length. Okay. Okay, so if we think about the steps to solve this problem, there's a couple of things that we first need to like think about here. So I think I want to solve this just with like, so the intermediate data structure here, I think I just want it to be some integer. So not really a data structure at all, just a piece of data. I'm not using like an object or an array to store the longest subsequences or anything. that's how I plan to do it. So I think the first thing we want to do is to declare the variable longest length. Okay, and then we can initialize that variable to I think we initialize it to we just initialize it to -1. Its initial value doesn't matter so long as it's greater than 1. So long as it's less than 1, because that would be the minimum length, I think, even if we had some test case that was just like of length 1, that's like the minimum value or the minimum length of our integer array nums. Okay, so this value is relatively arbitrary, but then the next step would be to essentially traverse input or traverse the indices, traverse the elements traverse the integer elements in nums, and for each element, and at each index, we want to compare the value at I and I plus 1. So essentially we're looking, okay, left element, for this example here, it would be 1 initially when we first start looping, and right would be 3. So we want to check to see if the one on the right is greater than the one on the left. And if it is, then we would want to maybe increment longest length, or maybe have another variable that stores the current longest length. Okay, so I think I'm going to just make this really clear. So we want to declare left and right, and those will be associated with these values. For the values, compare left, right to right. If right is greater than left, that's silly. If left is less than right, to keep it at the correct sides of the less than sign. So if left is less than right, then we want to increment current length by 1. Otherwise, we would want to essentially check, or just I guess zero out current length. Yeah. So then we just reassign current length to 1. Okay. And I want to remember to not forget to initialize current length to 1, because that is the default length of a character of length 1. Okay, so we've got that going. Reassign current to 1, and then during every iteration, we want to check to see if current length is greater than longest length. And if it is, then we want to reassign longest length. So if true, reassign longest length to current length. Okay. Okay, so I have sort of an algorithm. It kind of looks like an algorithm anyway, but before we finish, we need to remember to return longest length out of our function. Okay, so if I were to do a little test drive of this. Let's grab this test case and let's just walk through it manually. So longest lang. Actually, let's just leave it at longest, and this is going to be -1, and current, and this will be 1. Okay. All right, and then this is our nums. All right, and we just want to step through the elements, right? So we're going to traverse this array, and we need to remember to traverse this up to but not including the last element. So it would be like nums lang. So the ending condition would essentially be like nums lang is less than, or nums lang minus 1 would need to be less than I. So I, or rather it must be I must be less than this value. So for an array of length 5, the length is 5. So essentially, as soon as I is equal to 4, we don't want to go past that. So essentially, we'd be looking at these two elements at index or at I0, then these two elements at I1, these two elements at I2, and these two elements at I3. So going up to but not including this value, which is 4 for this input. Okay. So if we're traversing, we're seeing, okay, left is less than right. So we'd want to increment current by 1. So now that's 2. And we would check to see, is current length greater than longest length? It is. So then we would reassign longest to 2. Okay, and then we move to the next pair of integers. I is 1, so 3 is in fact less than 5, so we increment current lang and longest, and move to the next iteration. So now I is 2, and so we're seeing, okay, 5 and 4. 4 is not greater than 5. So we're evaluating this branch, and this is where our code is wrong, I believe. So maybe we need to do this first. If we did it first, yeah. Yeah, if we did it first, I think that would actually make sense. Let me let my dog out real quick. So if we did it first, then we would still have the current value of current lang before we get rid of it. So the current lang at this stage would be 3. Then we would breeze. Okay, so I think that makes more sense. So if we were to step through this again, this is -1, this is 1. Okay. So incrementing, so we would check to see if current is greater than longest. It is, so we reassign that to 1. Then we're checking to see if 3 is greater than 1. It is. Then we increment current. Okay, I think this makes sense. Yeah, so let's implement it with some code. Okay, great. So first things first, we want to declare some variables. Okay. And now we want to traverse the integer array nums. I think we're just going to use a standard for loop here. Now we want to check to see if the current length is greater than longest length. And if it is, then we want to reassign longest to the value of current. Then we want to declare left, right. Okay, so left nums at the current index, and let right nums at the current index plus 1. So again, we're thinking left, right. Okay. Now we need to basically we need to compare left and right. Okay, so let's do that. If left is less than right, then we know we have that condition met. So we want to increment current length by 1. Otherwise, we want to reassign current length to 1. Okay? And then we want to return out longest. So let's do a little, another manual session here. If you look at this test case, we're traversing nums, left and right. So then longest is reassigned to 1 here. And then we're declaring some variables and initializing them to some values. So left is 1, right is 3. We're comparing those two values, and we're incrementing current. So yeah, this seems good. I'm going to give it a whirl. Okay, we're passing the given test case. Let's take a look and see how we did with the other test cases. Okay, so 1, 3, 5, 7. Why is our output 3 instead of 4? Let's take a look and see how many test cases we actually passed. Fair number. So what makes this test case unique? Well, it doesn't have any situation where the chain is broken, right? Okay, so we're thinking about this test case. Where is our algorithm going wrong? Okay, so just close out of there. So essentially we're just traversing the entire array, and for all of them, it is longer. Okay. So the values we're comparing are 1, 3, 3, 5, and 5, 7. And so the initial value of current is 1. So then once we reach our loop, and we compare them, then so there's essentially like 3 comparisons happening throughout. So that should produce 4. Yeah, our output is returning 3. Or our function is returning 3 instead of 4. Okay. Okay, so I think the problem here is that we're just not, like, our solution doesn't account for a situation where they're all continuously increasing elements. So I'm guessing there's like, I need to have I think this, I might need to have another one of these at the end. If I paste that here, I think we should see the correct answer. So let me just run our code. Okay, and we're passing all the test cases. So the problem was essentially my solution didn't account for a situation where they're all continuously increasing, and this was being checked before this operation on each iteration. So it didn't. Yeah, that's just that's a problem. So I think if I were to wondering if I move this down, that makes sense. If I move this line down here, and then I can just comment this out. Does that also pass the test case? It's not. Okay, so I'm just going to leave it how it was, since that was passing. But yeah, thanks for watching. This was super rocky as a result of my dog Rocket needing to go in and out so many times. But yeah, thanks for watching. And yeah, see you in the next one.